So here's the last video for chapter 2.2. I just want to review the idea of sketching graphs now. In the past, in more traditional calculus classes, we would do a lot of this by hand, but now because we have Desmos, sketching graphs by hand is not as important, but we still want to know the ideas and why those values are maximum minimums, why they're points of inflection, where do they occur, how that's related to a derivative, and so forth. So looking at kind of your last set of notes here, strategies for sketching. Again, we're going to be using Desmos to produce a graph, but again, you want to keep in mind when we're graphing and we're looking for these extrema and points of inflection, important parts of the graph, we're going to be looking for first and second derivatives, right? We want to use those to find critical values. In order to do that, we need to be aware of the domain of the function, right? Is it all reals? Is it from negative infinity to positive infinity? And so this next piece is critical values of the function, which we've already done. F prime is equal to 0 when and f prime doesn't exist, right? Those are important values for the first derivative because that can then tell us where we have extrema, maximum or minimum values. And then we go ahead and find out where this occurs. You plug those critical values back into the function. We then are interested in where the function is increasing and decreasing, right? And in that case, again, that's is where in order to do that, right, we're then interested in the second derivative, where f double prime is less than 0, f double prime is right, we're looking for those derivatives, the second derivative, and then that tells us again in relationship if we have a relative maximum or minimum. And so looking at that, when we're analyzing a graph, we want to know if it's increasing or decreasing. Does it produce a max or minimum value? Right, and again, these are just the rules. We already went over. You can reread them again. And then we ended kind of with this idea of concavity and points of inflection, looking for where we might have points of inflection, set the derivative equal to 0, second derivative equal to 0, or where it does not exist. We want to find values. And in this case here, we look at concavity, and again, that's that shape of the curve. And one way we then, again, determine that is by plugging in, use a substitute test, right? You plug in values to determine whether it's concave up or concave down, and it depends on the value of the second derivative. And then with all that information, you could sketch. But again, because we have, and so we're just going to walk through example 2 just to kind of go through that, because in the end, when you have a function like this, an equation like this here, we are going to use Desmos to graph it. So you can then go ahead and see here's the function, here's the sketch of the graph, and then being able to pull out those important points. Where do those important points come from? Again, I like this look here of this overall picture here where you see the functions increasing, concave down. There's a relative maximum when it's concave down, point of inflection when it changes concavity, a minimum, but you can also see the first derivative where we're talking about here. This is our f prime, and then we look at f double prime here to kind of look for concave up, concave down. So this is a nice picture. Really study this image here where you see it's concave down. This graph is concave down. And when you hit this point, it turns concave up, and you have that point of inflection. And then again, where do you get all those values again? This is a perfect example to kind of walk through and look at where you take your derivatives, find out where they're equal to 0. You found critical values. And so you found critical values here. Then we had the other, you found it for the first derivative. So you have those potential critical values. The second derivative, you took it here, the inflection point, set that equal to 0, and then you found for the second derivative, which was 6x, you have that point of inflection. And then we go through increasing and decreasing where you can see where it changes direction, where you have the relative maximum. You found that it's negative here, right? And then when you plug in the other critical point, it's positive. And so in, again, those situations, you reread that, you can see there's a maximum. It's concave. You have the concavity here. Okay, but you can see the second derivative. This is the first derivative is positive because it's increasing and then decreasing. And when you have that, you end up with a relative maximum increasing and decreasing. Again, that's connected to second derivative because, again, the second derivative is determining what's happening with the first derivative. Does it go from positive and negative, the slopes? So that's an example you want to walk through, which then you can then find the concavity. This is a perfect example to look at. And so then quick check 3, we will we'll start class using quick check 3 as kind of a review of everything for us in this section. And that's it.